Hello everybody, this is Mr. J here, and I'm going to teach you about solubility curves today. So what is a solubility curve? Well, a solubility curve tells us how many grams of solute can dissolve in 100 grams of solvent at a given temperature. And here we have a graph of a solute that the solubility increases as temperature increases. Now there's a couple different points on this graph that I want to talk about. First, under the curve means that you have an unsaturated solution. This means that you could add more solute at that particular temperature and still dissolve it in the solute. It will still dissolve. Now let's say we keep adding more solute to the solvent. We move from point A to point B here. And once you're on the curve, that's saturated. At that temperature, no more solute can enter the solvent and dissolve in it. If we cool off the mixture, the homogeneous mixture that a solution is, if we cool off at B, what will happen is some of that solute will drop out of the solution because it can no longer stay dissolved if we've cooled it down. And we're still on the solubility curve itself, so that means we're still at a saturated solution. Now, I just told you that you can't dissolve any more solute when you're saturated. Well, in some cases, you can, and we call that a supersaturated solution. Those solutions are extremely tenuous. They do not stay in solution very long, and if they are jostled or jiggled at all, the solution will release all the solute and back into a solid, and it will go back to the solubility curve. And so if we look at the chemistry reference tables, table G, this tells us how different solutes will dissolve in a solvent, solubility of them. And if we look closer, you can see that some of the lines are going up as we increase temperature, and others are decreasing as we increase temperature. And this tells us a little something. The lines that are going up are solid solutes, and the lines that are going down are gas solutes. So the solubility of a solid increases as temperature increases, but the solubility of a gas decreases as temperature increases. Let's take a little closer look at that in a second. After we have filled out this part of the properties of solutions concept map, we can describe both a solid and a liquid solute solubility using solubility curves, which is table G of your reference tables. All right, let's take a look at this. So let's say we have a solid solute in a dish, and we have a liquid solvent, the solute and the solvent. We're going to bring up a graph, and we're going to put some of this solute into the solvent, and it settles at the bottom. We're going to give it a stir, and it will dissolve. As it dissolves, it goes up, and we'll make sure that it's saturated. It's right on the line. How do I know it's saturated? Well, let's put some more solute in. It settles out. We give it a stir, and it doesn't dissolve. How can we get it to dissolve? Well, we've got to increase the temperature, right? So we're going to add some heat. And now if we mix it up, it will dissolve, and we'll move into that area right there. All right. So let's say the solute, a solid solute, the solubility increases with temperature, and fill that out on the concept map. How about the gas? Let's look at a cold cup of soft drink. This has gas solute dissolved in it already. It's dissolved, and we're at a saturated solution. As you know, once you leave a cup of soda out for long enough, it gets warmer. And as it gets warmer, its solubility of the gas decreases. The gas bubbles come out, and you have flat soda. And so on our concept map, we're going to write that down, that solubility of a gas increases with decreased temperature. You could also say that it decreases with increased temperature, but this is the wording we're going to use. All right, let's do some examples using solubility curves. So, with this solubility curve right here, how many grams of potassium nitrate will dissolve in water at 70 degrees Celsius? So we're going to go to 70 degrees Celsius, go up to the potassium nitrate line, and then move over and see what our answer is, and it's 35 grams of potassium nitrate will dissolve in 100 grams of water. What temperature will 100 grams of potassium nitrate dissolve in 100 grams of water? Well, let's go to the gram side this time and go over to the potassium nitrate and then down, and we see that it's at about 57 degrees Celsius at which this will happen. At what temperature and mass of solute are the solubility of salt and potassium nitrate the same? So we look at where the lines cross, and we look down first, and we see that we've got about 25 degrees Celsius for the temperature. And if we go across, we see that we've got 39 grams for the mass. Okay, as the water temperature is increased from 30 degrees Celsius to 70 degrees Celsius, how many more grams of substance A will dissolve in 100 grams of water? So let's look at substance A at 30 degrees Celsius, and we see we're at about 70 grams. Now we're going to increase the temperature to 70 degrees Celsius, and we'll see we're about 90 grams. All we have to do is take the difference, and we have our answer as option number 1. And that's about it for solubility curves. If you have any questions, just let me know.